Hi again, Sevda. I've got question 2 here now. I'm just going to go through sort of the major points with you on it. So with this chart, I think one thing that would be helpful is for you to have this, which sort of shows you where all the numbers are coming from in your chart. So you've got the sum of squares between groups value at 119.92 in the chart, and then the total at 153.48. So this value that goes in here is the difference between them. So if you just take 153.48 and minus the 119.92, then I think you're going to get 33.56. I think that's the value, but you should check that, okay? The same thing with the degrees of freedom. This 59 here is n minus 1 for the whole for the whole sample that you're working with here. And so your degrees of freedom need to add up there also. And so if you're, the reason is that here's n, this is your total sample size. And you're minusing k, the value that we used up here. And so, I'm sorry, I think maybe it should be 60, should it not? I think it's 60. So that should be a 6. Because then you're, because your total degrees of freedom will be minus 1 from both groups. And have I got that right? Your degrees of freedom? No, I'm sorry. I had it right the first time. Darn. Sorry about that. No, it's got to be a 5, because your total degrees of freedom is what you're adding up in this column, which is 59. Okay? So when we look at the MS value, again, this chart I think is really helpful. Maybe if you have it sort of printed off or something to go by. So this value is calculated, the between value is calculated using this formula. So you really are just taking the 119.92 and dividing by 5 there. And that's a divide. Okay, and the same thing down here, you're taking your 33.36 and dividing by 54. Okay, so you're going to get two really different numbers there. The two numbers that you get are the ones that you're going to use to calculate your F statistic, okay? So let's see if I can find a good color that shows up here. When you're calculating this, you want to just take those two values from your MS column and divide them, and the between goes on top. The between is the numerator and the within is your denominator. And so if you divide those values, you'll get your F statistic, and I think it's rather large. I think it's in the 30s for that one. And that's part A completed, because that's what they're asking you to do in part A, is just complete the chart. So that's everything in there that you need, okay? I think this bottom chart here is quite handy for that. So if you can maybe keep that somewhere printed off or something, it might help you if you have that in your notebook as you're working on these questions. So the second part of the question now is asking us to look at the F crit for this particular set of data. So let me just, sorry, I have too many things on the go here, and it doesn't know which one I'm trying to, there it is. There we go. Okay, so for our F crit, I've got the F distribution table here for the alpha 0.05, and we need the degrees of freedom, first of all, to be figured out. And so these little circles and things like that, sorry, these are left over. So we need to ignore those. Let's move this chart somewhere else so that we don't think that we're working with those values. Okay, I'm going to work in a different color, so everything I write on here will be red, and that is for the Part B answer, okay? So for our degrees of freedom, for the numerator, we said that was 5. For the denominator, we said it was 54. So actually what we have to do here is, I shouldn't have started circling. Maybe if I make it just a wee bit smaller. Okay, what we have to do is go to the closest value. So 54, the closest value is going to be the 60 from our chart. So when we go across where 60 and 5 meet, it's this value right here, which is 2.37. So 2.37 is our F crit. And your F calculated, or your F test I have trouble saying that, statistic from your chart above, when you calculate it up here, I think you get an F value, something in the 30s. I think I got 38 point something like that. When you compare those, obviously we have to reject the null because our p-value is really, really small here. We have a 38.6 F statistic, so we're really, really in the extreme region for this curve compared to the F crit of 2.37. And so when we're looking at the question, do these test results suggest, oh sorry, that's in behind now, do these test results suggest that a significant difference exists between any of the populations? The answer in this case would be yes, because we had to reject the null, which is that there's no significant difference. And so in this case, it does seem to suggest that there is a significant difference between the populations.